So, good morning, all. So, today we are going to see the remaining problems which are related to the empirical equation. Okay. So, as I told, the empirical equation should be in the form of del H0 RT, del A T plus del B by 2 by 2 into T square plus del C by 3 into T cube. So, we have solved a problem. So, first they will give the standard heat of reaction directly. If it is not given, we have to they will be giving the data for finding the standard heat of reaction. That is, standard heat of reaction is equal to standard heat of formation of products minus standard heat of reactants. So we have to find that, and then they will give the A value, B value, C and D values. So when you are giving, they will give into 10 power 3, 10 power 6, 10 power 9. So that should be taken as 10 power minus 3, minus 6 and minus 9. Already we have seen that when the Cp naught value is being taken. So same way del A will be of products minus reactants. Okay, products minus reactants. But only thing what you should consider is, when you are doing products minus reactants, we should multiply with the number of moles. So for example, here SO3 number of moles is 1. So 1 into 22.036 minus, so 1 into 24.771 plus 1 by 2 into. So these two are reactants and these two are products. Same way you have to find for del B, del C and del D, and after finding you can final answer into 10 power 9 minus 9, final answer into 10 power minus 6, like that you can calculate. Once that is done, okay, so after finding, just a second, after finding del A, del B, del C, del D and all, okay, you can just substitute in the equations, okay, substitute in the equation, and you will be getting an equation in the form of del H0 RT is equal to del H0 minus. Now, we have to take the temperature as standard condition, that is 298 Kelvin. Okay, standard condition, that is 298 Kelvin. So at that time, what happens is del H0 RT, whatever will be found will be of standard conditions. So now substitute this del H0 RT value, whatever we have found or given, and then T is equal to, sorry, not 298, T is equal to 298 Kelvin. Okay, T is equal to 298 Kelvin. You will get the value of del H0. Okay, you will get the value of del H0. And after that, substitute the del H0 value. Okay, and you will get an expression with respect to T. So this is called as an empirical expression. Suppose if it is not any temperature like that, it is not given, we have to stop like this. Sometimes they will ask, some other temperature will be given. So in this problem, they were given as T is equal to 773. So we have got the standard heat of reaction. Same way, and next problem, another two more problems we have. So this is obtain an empirical equation for calculating the heat of reaction at any temperature T. So they have given us any temperature T, not specifically temperature is not been asked. For the reaction, CO plus 2H2 gas gives CH3OH, and del H0R data is being given as minus 90.4 N. Previous problem, they have given the standard heat of formation data, del H0F data, and from this we have found the del H0R. So R means this condition will be at 298 Kelvin. Okay, but here del H0R data has been already given. Only thing we have to do is we have to find del A, del B, del C, del D. Okay, so now what is the formula? We will write. So the formula is del H0RT is equal to del H0R plus del AT plus del B by 2 into T square plus del C by 3 into T cube plus del D by 4 into T power 4. Now this data has been already given. Okay, del H0 RT is being given as what? At temperature of 298 Kelvin is given as minus 90.41. Okay. So now first we have to find del A, del B and del C and all. So the equation is CO plus 2H2 gives CH3OH. So del A will be what? 21.137, 1 into 21.137 minus 1 into 29.0277 plus 2H2, that is the 2 into 28.6105. So now we will write del A. Del A is equal to 1 into 21.137 minus 1 into 29.0277 plus 2 into 28.6105. So you will get the answer as minus 65.117. Okay, same way now del B. Del B is same. Okay, 1 into 170 sorry 70.843 minus 1 into minus 2.8165 plus 2 into 1.0194 into 10 power minus 3. 3, so you should take it as minus. Remember this is minus 6 and this is minus 9. Okay, so now you will get as 1 into 70.843 minus 1 into minus 2.8165 plus 2 into 1.0194 into 10 power minus 3. Okay, so you will get the answer as 79.6207 into 10 power minus 3. And the next is del C. Same way del C we have to find. It is 1 into 95, 25.86. This is 25.86 minus, okay, 1 into 11.6437 into 2 into minus 0.1476. So you will be having as 1 into 25.86 minus 1 into 11.6437 plus 2 into minus 0.1476 into 10 power minus 6. Don't forget to take this into 10 power minus 6. So you will be having as 14.515 into 10 power minus 6. And the next is del D. Okay, same way you have to find for del D also. Del D is 1 into minus 28.497 into 10 power minus 9 minus 1 into minus 4.7063 plus 2 into 0.769 into 10 power minus 9. So the answer what you will get is minus 25.3287 into 10 power minus 9. Okay. So now what we have to do means we have to substitute in the equations all these. So you will get del H0 RT is equal to del H0 minus 65.117 1177 plus 79.6207 into 10 power minus 3 by 2 t square plus 14.515 by 3 into 10 power minus 6 t cube minus 25.3287 into 10 power minus 9 by 4 into t power 4. So now divide the equations. So you will, this is del h0, okay, not del h0 r, this will be just del h0. Okay, so you will be getting as del h0 minus 65.117t, okay, 117t, okay, plus this is 7 and this is t. Just a second, I will write clearly. 65.117t. Okay, 117t plus, when you are dividing this, you will get 39.8103 into 10 power minus 3 t square, okay, plus 4.8383 into 10 power minus 6 t cube minus 6.3321 into 10 power minus 9 t4. Okay, so now what is the answer is they have given this is one expression we have got. So now del H 0 R is equal to, that is del H 0 R T is equal to minus 90.41 kilojoules per mole. Okay, kilojoules per mole. And uh, kilojoules per mole. Okay, either you can keep it in joules per mole or kilojoules per mole, or you can convert it into joules per mole. So we are converting this into joules per mole. Okay, always keep it in joules per mole. So you will get it as minus 90410 joules per mole at 298 Kelvin. Okay, 298 Kelvin, because the CP naught data, whatever will be given, will be in kilojoules per kilomole Kelvin or joules per mole Kelvin. Okay, so here del H 0 R is in kilojoules per mole, and we are taking this data. Usually better convert it into joules per mole. Okay, so you will get it as minus 90410 joules per mole. Okay, that is del H 0 RT at 298 Kelvin. That means standard condition is what? 298 Kelvin is what? 90410 joules per mole. Now, in this equation, substitute 90410 for this del H 0 RT and find del H 0. So, you will get minus 90410 is equal to del H 0 and T is equal to 298, and substitute T is equal to 298 minus 65.117 into 298 plus 39.8103 into 10 power minus 3 into 298 square plus 4.8383 into 10 power minus 6 into 298 cube minus 6.3321 into 10 power minus 9 into 298 power 4. So you will get the value for del H 0 as minus 74,620.13. Okay, 64. So now this is for del H 0 value at 298 Kelvin. Now they have asked an expression for del H 0 RT at any temperature T. So now for this same expression, just we have to substitute the del H 0 value and T will remain as such. Therefore, del H 0 RT will be equal to minus 74620.13 minus 65.117 plus 39.8103 into 10 power minus 3 t square plus 4.8383 into 10 power minus 6 t cube minus 6.332 into 10 power minus 9 t power 4. This is the empirical expression for standard heat of reaction at any temperature T. Suppose for instance previous problem they have asked for 773. So after finding this expression, we have substituted T is equal to 773 Kelvin. So what we have to do means, first from the given data we have to find del A, del B, del C, del D. Okay, and after that what we have to do? We have to substitute in that formula, and then we have to find the equation where you will get this. And then next step is we have to substitute for this, and T is equal to 298 Kelvin, and you will be finding the value for del H 0. Okay, del H 0, you will be getting the answer. Now after getting the del H 0, same expression you should submit, you should substitute the del H 0 value without substituting any value for T. This is called as the empirical expression. Okay, same way one more problem you people can solve it. That is they have given CO plus H2O give CO2 plus H2 and del H0 R. That is del H0 value, del H0 RT value is given. Now same way, you have to find del A, then you have to find del B, and so multiply with 10 power minus 3 Then del C you have to multiply with 10 power minus 6, and del D, and you have to multiply with 10 power minus 9. And the same answer will be like, and one more thing is, after you are getting del H 0 or convert it into joule per mole. Okay, that is one thing. So now what happens is, del A value after, what is the formula is, del H 0 RT is equal to del H naught plus del A T plus del b by 2 t square plus del c by 3 t cube plus del d by 4 t power 4. Okay. So now you have to find. So all are 1 is to 1 only. 1 mole CO, 1 mole H2O. So what you have to do? Just these two are products and these two are reactants. CO and H2, sorry. These two are reactants and these two are products. So what happens? This into this, this plus this minus this plus this. That is products minus reactants. Okay. Find same way, find del A, del B, del C, del D. So you will get del A is equal to, do the calculation, I am just giving the answer. Del A is minus 11.5438, del B will be minus 68.0404 into 10 power minus 3, del C is what, minus 66.0526 into 10 power minus 6, del D value will get us 19.8226 into 10 power minus 9. So now del H 0 R value RT at 298 Kelvin, whatever the given data we have to take. That is minus 41.16 kilojoules per mole. So I told always, this is another one important point you should remember, convert it into joules per mole. Okay, convert it into joules per mole. So you will get as 4160 joules per mole. So now after finding all these expressions, you will get the value as del H0 RT is equal to del H0 minus 11.5438 T minus 68.0404 by 2 into 10 power minus 3 plus, sorry, not plus, minus 66.0526 into 10 power minus 6 by 3 into t cube plus 19.8226 into 10 power minus 9 by 4 into t power 4. So now solve this again. You will get del h 0 or t is equal to del h 0 minus 11.5438 t plus 34.0202 into 10 power minus 3 t square minus 22.0175 into 10 power minus 6 t cube plus 4.9556 into 10 power minus 9 t power 4. So, okay. So, now we have to evaluate del H 0. For that, what we have to put? Substitute del H 0 RT is equal to minus 41160 joules per mole, and the previous equation you have to substitute T is equal to 298 Kelvin. So del H 0 RT is given, just we have converted it into joules per mole. Okay, so now after putting all these values and solving, you will get the equation as minus 4019.19. So now same, just you have to substitute this del H 0 value over here, and you have to write the expression for at any temperature T. That is minus 40019.19 minus 11.5438 T plus 34.0202 into 10 power minus 3 T square minus 22.0175 into 10 power minus 6 T cube plus 4.9556 into 10 power minus 9 t power 4. This is the empirical expression. Okay. So with this, the module of energy balance is completed. So some extra problems for your practice, I will be sharing it in class. Okay, in the notes. Thank you all.